Hello class, let's continue with exercise 2D, and in this one, which is mostly about graphs of functions and relations, you were uh, you were very confused in here because I suppose there are some of these which on which you have difficulty. For example, I cannot believe that all of these presented any difficulty for you. They should have not, but probably this one K and L, these ones are, yeah, I mean, this may be difficult for you at the moment, and I understand. So let me address this K and L exercise problem. What are we trying to do here in problem number one? They're giving you relations, whether as tables, mappings, graphs, sets of ordered pairs, etc. And you need to state whether they represent a function or not. And if they are a function, you need to state the domain range. So what is the problem with this one? What is the difficulty with this type of function? The difficulty is that it presents this type of behavior, right? Like over a certain part of the domain from minus infinity to minus 1, it behaves in this particular way, right? And then from minus 1 to 1, we have actually no function or no graph. And from 1 to infinity in the x-axis, we have this behavior, okay? This is perfectly okay for a function, guys. It's perfectly okay because once again, what is a function? A function is a set of ordered pairs. That is the most fundamental, most precise definition for a function. It's a set of ordered pairs with a particular constraint or restriction, right? I'm not gonna go in there once again, but you should understand that these graphs, they are actually sets of ordered pairs. All of these graphs are composed of points which are ordered pairs, right? And so this set of ordered pairs plus this set of ordered pairs are in themselves another set of ordered pairs, right? So there's nothing really weird about this. Nothing really weird. What is this called? This is called a piecewise function. Piecewise function es como una función seccionada. Why is it called this way? Because over certain parts of the domain, it presents a certain behavior, okay, and over some other part of the domain it presents a different behavior, okay, which is perfectly all right. And by the way, there could be sections in the domain that have no function, right? And in such case, actually what that means is that I mean, this in fact, this little section from minus 1 to 1 is actually outside the domain. This is not part of the domain of this function. So this is a piecewise function. All right. Is this a function? That is a question, right? The question that they asked us in the problem. Run the run the vertical line test, and as you can see, the vertical lines always cross the graph at most at one point. Therefore, this is a function. Period. Period. Okay, now what is the domain of this function? Okay, let's see. Let me call this function f, and so the domain of f is gonna be the following. You need to check basically over what values of x you actually have a graph on above or below, right? From minus infinity to minus 1, including 1, you have function. There, therefore, that's part of the domain. From minus infinity to minus 1, including. But also, you have this jump, right? You have no function over this part, so this should not be included in the domain because you have no function here for these values of x. There is no corresponding value of y. And then from 1 onwards, you start having function again. So the function should be, I'm sorry, the domain of this function should be from minus infinity to minus 1, including union from 1 to infinity, like so. Remember, this symbol union basically serves kind of like an addition. It's like all this domain, all this part of the domain from minus infinity to minus 1, and then we make this jump from 1 to infinity, and that's it. So it's all of these numbers plus all of these numbers, and that's made explicit through this symbology. So that's the domain of this function. Okay, what about this one? We have another piecewise function. What is a piecewise function? It's a function that have different behaviors over different parts of the domain. From minus infinity to 0, it behaves like a parabola, and from 0 to plus infinity, it behaves like a horizontal straight line. Okay, so it's a piecewise function. Is it a function though? I mean, I'm already calling it a function, but is it a function? Yes, run the vertical line test, and you will notice that it always cuts the graph at most at one point. Therefore, this is in fact a function. Uh, I'm making a mistake. Sorry, guys. Forget about what I just said. Uh, it's mostly correct, but you should notice this. You should notice the following. There is a very peculiar thing happening over here with these 2 points. Can you see this point is actually part of this graph, and this point is part of this part of the graph, right? And so what this is telling you um, is the following: that for this particular value of the input for 0, when x equals 0, particularly, you can have two different values for the output. For the first part of the graph, which is this one, y is also 0. For x equals 0, you get y equals 0. And for this other part of the graph, for x equals 0, you get y equals 4. So this breaks the definition of function, right? Because for this input, you get this and this different outputs, and therefore this is not a function. This is no function. Just because of this behavior in for this particular value. If this value were not included in this part of the graph, like let's say instead of a filled point, we had kind of like a void point representing that this point is not part of this graph, then this will be a function. Okay, because for x equals 0, if the function was drawn in this way, like instead of a filled or solid point, it's just a void, like a point like this. Okay, we don't fill the point. Then if that was the case, for x equals 0, the corresponding value for y would be 4, and this complies with the definition of function. But this is not the case. What these two graphs are telling you is that for x equals 0, you have two different values of y, and therefore that single thing breaks the definition of function, even if the definition of function complies in the rest of the graphs. Okay, so that was problem number one. Problem number two: use your use Desmos at the moment to graph the following functions. Sketch the graph and state the domain range. Well, this is quite simple. All you have to do is go to Desmos, plot these graphs, and then check the domain range. We have gone over this several times. So I don't need to do that again. Number three, draw the graph of a possible function for each of the following domain and ranges. This is actually quite simple. I don't know why you had difficulty with this. You can make anything. Okay, like it's more difficult not to think of something than to think of something. Domain, all the real numbers. Range, all the real numbers. Okay, so for example, a linear function such as this, that it extends in both directions infinitely. If you notice, the domain of this function f is all the real numbers, and the range is also all the real numbers. What does that mean? That the graph will sweep or will cover all the values in the x-axis and in the y-axis. It's that simple, guys. It's that simple. B, the domain from minus infinity to infinity, which is all the real numbers, right? And the range from 3 to infinity. Okay, so I draw my Cartesian plane. In the domain, I have no restrictions, so my graph can cover all the x-axis. But in the range, I start from 3 and I go upwards only. So this is 1, this is 2, this is 3. My graph, guys, whatever graph I'm gonna draw cannot be below this. I'm gonna make a dotted line like so. My graph, whatever I draw, cannot go below this blue dotted line. Okay, so for example, we can draw this thing. Look, I'm gonna draw a parabola, a very open parabola, like so, like that. Okay, and it continues in this direction, right? And the same in the other direction. Okay, if I do this, I'm gonna be complying with the domain, which is from minus infinity to infinity. It's basically it's ranging, it's covering all the x-axis, but the range only goes from 3 to infinity, right? So that's it. You can draw something like this. You can draw something also, you can also draw different things, right? But this is what I drew. C, the domain from 0 to 6, including 0, excluding 6. Okay, let's draw. And the range from minus 3 to 2, including minus 3, excluding 2. So let's actually draw once again those dotted lines so that I know what are my restrictions. The domain from 0 to 6, which is from this line to this line. This is 1, 2, 3, 4, 5, and this is 6, right? So my graph should be contained between this line and this line, so that the domain goes from 0 to 6, right? My graph cannot escape this strip, basically. And the same happens for the range from minus 3 to 2. So minus 1, minus 2, minus 3 to 2, 1, 2. Okay, so you can see that my whatever graph I'm gonna do cannot escape this section, actually. This section, this little, it's kind of like a square or a rectangle. So I can draw whatever I want. I'm completely free, guys. Like, as long as it passes the vertical line test, you're fine. For example, you can do something like this. I don't know, like, there you go. That's it. That's it. You see, this is a graph for a function because if I run the vertical line test, this thing passes it. That's it, guys. And it also complies with the domain from 0 to 6. Maybe, by the way, since 0 is included in the domain, I should make explicit that this point is included. I fill the point, lleno el puntito, and the number 6, which is this one, is not included, so I should make this void, void point, filled void. And that's about it. That's about it. Yes, that's right. So that's it, guys. This complies with this criteria. And for letter D, the domain should be greater than 0 and the range should be greater than 0. Y, X. So, for example, something like this, void, and then something going like this, right? Why void? Because it's telling me that the domain is necessarily greater than 0. If I make a fill point, I would be saying that the 0 is being included, but that's not what I want. So I'm gonna discard that point, and then I'm gonna draw kind of like a half a parabola. So the domain is gonna be for, all the numbers greater than 0, and the range also all the numbers greater than 0. This parabola extends towards infinity in both directions, in to the right and upwards, and that complies with this. Okay, and so that's how this exercise works. Number 4, consider the piecewise function. This one, this function, guys, behaves in this way over this part of its domain from 0 to 6, and this function f behaves in this way over this part of the domain from 6 to 10. Okay, so let's actually draw this. If you okay, let me minimize this thing. Let's do this. Okay, how does this work? Like I'm gonna do it in Desmos in a moment, but I want you to realize that this can be done completely by hand. I repeat constantly, guys. Whatever you can do in Desmos or any calculator, you can do by hand. There is nothing special about a calculator. So what's up with this function? How does it behave? I'm gonna draw the function over here. X-axis, y-axis. If you notice, the domain of this function goes from 0 to 6 and then from 6 to 10. So basically it goes from 0 to 10. So this is 0 and then 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all my function, guys, ranges or goes from 0 to 10. Okay, it cannot escape this zone. I cannot have graph over here or over here. Okay, it's all contained in within this zone. And how does it behave? It behaves like this: 1/3 of x plus 2 and minus x plus 10, which are, if you understood anything of something about straight lines, you should realize that these are straight lines. These are straight lines. 1/3 x plus 2. This has the same. Wait. Uh, well, maybe f of x equals one third of x plus 2, and f of x equals minus x plus 10, right? These are straight lines. Remember, these are the slopes, minus 1 and 1/3, and these are the intersections. Okay. Okay. Now, how do you plot these lines by hand? What you have to do is this: over this part of the domain from 0 to 6. 1, 2, 3, 4, 5, 6, 10. All you need to do is give some values to the x and find the corresponding value of the output, right? Give a number to the input and obtain the number for the output. So for example, if you gave x the value of 0, then f of x is going to be 2, right? So for this one, we have 0, 2. And if you give x the value of 1, you get 1/3 plus 2, which is 2 plus 1/3, that's 7/3. If you give x the value of 3, I'm doing this very quickly in the mind, right? This you will get 4. No, I'm sorry, 3. 3 comma 3. Okay, and you do the same for this one. Okay, give x certain values over its domain, which is from 6 to 10. From 6 to 10. For example, if you give x the value of 7, you're gonna get minus 7 plus 10, that's gonna be 3. And then if you give x the value of 8, you're gonna get 2, 9, 1. That's it. With these points, guys, you're ready to draw the lines. 0 comma 2, that's over here more or less. Well, let me actually draw 1, 2, 3. Yeah, it's enough. 0 comma 2, that goes in here. 3 comma 3, 1, 2, 3, that goes about here more or less. And that's it, guys. That's it. I have enough information to draw my line. That's about it. You see, this line, 1/3 of x plus 2, is this one. And it should go only from 0 to 6. I cannot extend it, like, it cannot go over over 6. It cannot pass like this. Why not? Because the function behaves like this only over from 0 to 6. You should understand that. And then from 6 to 10, it behaves like this. So let me draw this other line. And I'm going to draw it by using these points. 7, 3, 7, 3, 8, 2, 9, 1, kind of like this. It's gonna, I mean, if it's gonna look a little bit like this, a little bit like that. It's gonna look like this, more or less, guys, more or less. Of course, if you drew it more carefully, you're gonna be more. It's gonna be better, right? We're gonna check in Desmos in a moment. So find each value f of 6. How do I calculate f of 6? All you need to do is this. This input, of 6, to what part of the function is, in what part of the function is this input? Is it in the first one or in the second one? It's gonna be in this one, because as you can see, 6 is included in this domain but is excluded from this one, from this part of the domain. So this is the part that you should consider when calculating f of 6. And basically all you need to do is basically like we always do, substitute 1/3 times 6 plus 2. This is going to be 4. And f of 8. So now what's the value of the function f for an input of 8? So 8 is in the second part, which is this part of the function, minus x plus 10. So I need to substitute the value in here. So it's going to be minus 8 plus 10, which is 2. And that's it. F of 6 is 4, f of 8 is 2. That covers this this letter. Sketch the graph of f. It looks more or less like this. We already did it. Write down the domain and range of f. The domain is from 0 to 10, because that's the part that the graph covers. From 0 to 10, both including, because as you can see, we have greater or equal for 0 and we have less or equal for 10. So both of these numbers are included in the domain of this function. And the range goes from 0 to, for this particular value, 6, I think 7, 3. Maybe it's gonna be better if we actually draw this thing, because I don't want to be telling you lies. Let's draw this thing in Desmos in order to get the range. Okay, by observing the graph of this function, we will be getting the range. Okay, so let's do it. 1/3 of x plus 2. Okay, and the other function, the other part of the function is minus x plus 10, right? Okay, so look at this, guys. Look at this. They intersect at this point, and remember, we only go from 0 to 10. Okay, all, I mean, I think we can, from 0 to 6. There you go. You see, I'm making that, I'm telling Desmos to draw this graph only over this interval, which is this part of the domain, right? Like only over here, from 0 to 6, including both numbers, and only that part. You see? Look at this. And therefore it's just this red section. And I'm going to do the same for this one. This one goes from 6 to 10, including. From 6 like this. Okay, this is the one. This is the one. How well did I do it? Yeah, can you see? It's pretty much that stuff. You see? That was my look. This was my sketch, and I did it by hand. So, okay, this is the graph of this piecewise function. It goes from 0 to 10 in the domain, and it goes from 0 to 4 in the range. Can you see? It doesn't go beyond 4. It doesn't go upwards. It just goes from 0 to 4. So that's the range. The range is from 0 to 4. And that completes this exercise, I believe. Yes. And number 5, consider the graph of the piecewise function y equals f of x, where x goes from -3 to 6. So this is the domain, from -3 to 6. Find the equations for the function, including an interval of the domain that applies to each part. Okay, basically, guys, you have to find the equation of each of these straight lines, and you know how to do this. You should know. You should know. We have already worked with the straight line, so you should know that if I wanted you to find the equation of this line, okay, we have three lines. We have this line, and this line. Let's call this line 1. Let's call this line 2. Let's call this line 3. Okay, line 1 goes from -3 to -1 only. Line 2 goes from -1 to 2, and line 3 goes from 2 to infinity. No, to 6. How do you find the equation of this line? Just take a look at the points. You have this point, for example, this point and this point. What is this point? This point is -3, 3. What is this point? It's -1, 1, right? And if you have 2 points, you should remember that we looked at this form of the line, right? Okay, so this is the slope, the point slope form. Okay, and all you have to do is get the slope by using these 2 points. You should know how it's done. Get the slope of this line, and then by the way, it's gonna be -1. Get it on your own. The slope of this one is gonna be -1, and then use either point, either this or this, in order to actually find the equation of this line. So I'm gonna use this one. I'm gonna use this point, -1, 1. So it's gonna look like this: y minus y1, which is this number, equals the slope, which I said it was gonna be -1. Get it on your own though, times x minus x1, which is this coordinate of this particular point. That's it. So this is the equation, guys, and then you can drop the parentheses by properly, right? Like you can do this: y minus 1 equals minus um, x, and then minus times minus, that's gonna be plus 1. That's it. This is the equation, guys. Y minus 1 equals minus x minus 1. And then, I mean, this is already okay. This is a little more simplified. And then if you want to simplify a little more, you go like this: y equals minus x, after you add 1 in both sides, right? So that this is the most simplified version of the equation of this line, and that's how you get it. So I'm just gonna do this part. F of x is gonna be equal to minus x over what part of the domain? From -3 to -1. From -3 to -1. I'm going to include the -3, and I'm going to exclude the -1. Okay, why am I excluding the -1 in here? So that the next part of the function, which is this one, can start from 1, including, and then exclude this point, right? Like so, like something from minus 1 including and then excluding the number 2, right? If I did this, guys, this would be a mistake because then I would be telling you that um, no, it's actually the same. Okay, no, forget about what I said. It's too technical. Forget about it. Okay, it's just a minor thing. Okay, and then you do the same for this line. Like get the equation of this line and get the equation of this line and do this, right? Like you're gonna have a one part in here like this for each of these two also. I only took care of this part in here, and it's this one. You're gonna do this and you're gonna do the next, this and this. And that's about it, guys, for this exercise 2D.